Okay, so we're going to do video analysis of a football thrown by a student using Tracker. Now it's important to know the student's height so that things can be calibrated. So we're going to make a calibration stick. And we're going to put it from the bottom to the top of the student, who is 1.83 centimeters tall. Sorry, 1.83 meters tall, which makes him 6 feet tall. Then I'm going to create a point mass, and I'm going to track the location of the football as it's thrown. Now one more thing I'd like to do is move the origin, so we'll have the origin at the thrower's foot. And I'm going to track the location of the ball as it's thrown. Now, the graph on the right that's forming is actually showing how far over the ball is with respect to time. I'm going to change that so we can see how high the ball is with respect to time. I believe this is filmed at 30 frames per second, so what you're seeing here is increments of 1/30th of a second between one frame and the next. If you're doing this video analysis yourself and you're shooting the video, make sure that you are perpendicular to the plane of motion. That is, make sure you're standing such that the ball that's thrown is going across your line of sight, not towards you or away from you. And also, this part's very important, make sure the camera stays still. So if you keep your elbows down, kind of tucked into your body, you can hold your camera perfectly still. And don't be tempted to follow the ball with your camera. Notice how the trees in the background stay perfectly still. That's very important for the video analysis to work correctly. So if you're using Tracker, I created a point mass, and what you can't see is I'm holding down Shift and then left clicking to locate the location of the ball that I'm following. So this part's a little bit boring because we're following this frame by frame. But if you look to the right of your screen, you can start to see the parabola take shape. And again, we're looking at not the height versus the horizontal distance, but we're looking at the height plotted against time. We're then going to put a few key points from this parabola into Desmos and find the equation of the parabola that most closely matches this path. And those of you that have studied physics know that objects around the Earth accelerate at 9.8 meters per second squared, which means that the parabola's leading coefficients should actually be about negative 4.9. Okay, this part is a little hard to find the ball in the background. I'm kind of guessing where it is, judging by the catcher's hands. Maybe I found it again. So I think a few of the dots are not accurate. I'll just erase them later. Yeah, so I'm going to go here and just delete a couple of these dots are where I lost the ball with respect to the background, so I'm going to delete them. And as you can see, the ball follows a parabola. Now let's get some points off of here. When time is 0, the height of the ball is approximately 1.25 meters. So our first point is 0, 1.25. And then later on, at 1 second, the ball is approximately, that looks to be 5.2 meters above the ground. So we've got the point 1, 5.2. And then finally, at time 2 seconds, the ball is about 1.8 meters off the ground. So my final point is 2, 1.8. And I'm now going to put all of these points into Desmos. So I've got 0, 1.25. I've got 1, 5.2. And I've got 2, 1.8. Now we're going to try and find the equation of a parabola that's going to fit these 3 points. Obviously it's upside down, so I'm going to have something with a negative x. So I've got negative x minus 1 squared. And this has to be shifted upwards, so I'm going to add about 5.2 onto the end of that. And see how it's not quite steep enough? So I need to make this steeper. So instead of just a negative, I could make that a negative 2 or a negative 3. I'm going to go all the way up to negative 4.9. And see how that curve closely approximates the location of the ball. So the equation of motion for this projectile is negative 4.9 x minus 1 squared plus 2.5. So to recap, we're using Tracker. And Tracker is a free program that does video analysis. So you can take a video of an object moving, follow the location of the object that's moving, and it'll produce a very nice graph for you. You can see it stepping its way through here as the ball flies. When you're shooting a video to do video analysis, make sure that you are perpendicular from the motion. That is, the ball is going across your line of sight, not towards you. And also make sure that you're staying perfectly still with your camera. So any trees or anything else in the background should be perfectly still throughout, and the object that you're tracking is moving with respect to them. Also make sure that you know the height of an object that's in that plane of motion. In this case, I know the height of the student that's throwing the ball. And we'll use that to calibrate so that distances are measured correctly. Then you hold down shift, you track your point all the way across, and taking a few points and putting it into graphing software, we can then find the equation of motion that matches the movement of the ball. And from physics, if you're tracking a projectile against time, that magic number negative 4.9 is going to show up. Because if you apply a bit of calculus to this, it'll show you that the acceleration of the falling body falls at a rate of 9.8 meters per second squared.